Good evening, ladies and gentlemen, and it's very good to be back in Manchester, as has just been mentioned. I actually started my working career here in 1974 at Ferrantis at Wythenshawe. I didn't actually work for Ferrantis. I was what in those days was quaintly known as a clerk of works. And I was the clerk of works for the then British Post Office brackets telecommunications, building what in those days was very much a minority sport. We were building the very first packet switches, which you would now recognise as the underpinnings of the internet, well before internet protocol. And again, it's one of those great lost opportunities that a lot of the work that was done there, somehow we didn't actually manage to build on. But it left me with a great affection for Ferrantis, and I was very, very upset when they ran into a set of charlatans called International Signal and Control and sank without trace. They did have one bit of revenge, I should say, for those who are Ferranti aficionados here. Ferrantis, we built the experimental packet switch service for the UK, but they didn't win the contract for the main packet switch service. However, they did win the contract, because it was me, for testing the main packet switch service. And that was done in the United States. We weren't allowed to test it properly ourselves because we couldn't buy from the US, being the post office. We had to buy from Plessis, who would buy from the US. But I was resident in the US testing these big packet switches with a very specialised converted piece of Ferranti computer system. It's Ferranti Argus 700G. And one night there was a power flick, and the computer room had big plenums in it. And the big plenums stayed off, but all the computers came back on when the power came on. So when we came in the following morning, which was a Saturday, the temperature in the computer hall was 130 degrees Fahrenheit. Everything had burnt out in there, primes, TP4000s, which were the packet switches. The only thing that was still running was a Ferranti Argus 700G industrial grade mini computer, still running very happily, but it had big 5.5-inch floppy disks. And for those who are old enough, remember a 78 gramophone record, put something hot in the centre, it curls up. Well, the disks had curled up in the drives, so we had to dismantle the drives to get the disks out. But the 700 was working very happily. So there was a certain Pyrrhic victory for Ferranti engineering. So that's a bit of an aside, but it does explain why I'm so pleased to have the invitation here tonight, and so grateful to Andrew Mahan. Thank you for the invitation too. What I'm going to talk about tonight is again one of my key interests, and it's going to be about GNSS. However, it's also going to be in the context of the resilience of our infrastructure, which is an area that worries me a great deal. The Royal Academy of Engineering report that this is based on was actually published in March this year. I was a member of the team. It was chaired very ably by Professor Martin Thomas. But there's one, you never see the most serious typos. There is one typo in the report, and it's on the front cover, and it's still there, where it says global navigation. Well, actually, I've changed it. On the report, it says Global Navigation Space Systems, and it was meant to be satellite systems. But, so I've corrected it on this title. But none of us spotted it until it was actually published. We all read the inside. We didn't read the cover. So such is life. What I'd like to do is just set a context for you. And that context is all about the exponential growth in the capability of IT. And what I would suggest is the linked economic vulnerability that arises from it. Then I'm going to summarise the key findings of the Academy report. I'd like to share some results with you of a practical demonstration of what happens when you jam GPS, deliberately in this case. I also want to touch on something which is again greatly underrated for the damage it could do to our society, which is space weather. Certainly a suitably large space weather event would take out all of the GNSS constellations at the same time, end of story. And then to look at the main recommendations we had from the Academy report, and then give you some final thoughts. But I want to start with a story. And the story is a fable. It's not actually true, but this is the Christmas lecture. And as one of my friends in what used to be called Fleet Street once told me, why confuse a good story with the truth anyway? So this is a fable, and it's a fable about the invention of chess. And in that fable, chess is invented around about the year 600 AD in the court of the Emperor of China. Anyone here who has Indian antecedents will immediately leap up and disagree, but let's just leave it in China, because the story only works if it's in China. And the inventor of chess is a court functionary to the emperor. In my terms, he's a civil servant. And the emperor is mightily pleased with chess and does a very, very dangerous thing. He asks the civil servant what he'd like as his reward. And in this fable, the civil servant says, "Oh, emperor, I'd like 1 grain of rice on the first square, 2 on the second, and just keep doubling till you get to the end of the board at square 64. The emperor is not a mathematician, thinks it's entirely safe to agree. In the fable, he works out he's been had round about square 32. You can grow the rice to cover square 32 in that exponential progression in an area roughly equivalent to Greater Manchester. To grow the rice to cover square 64 is a bit more of a challenge. Anyone want to volunteer the land area required to do that? No, it's not fair. It's 2.5 times the entire surface area of the planet, including all the oceans, right? So in the fable, round about square 32, the emperor works out he's been had, and he has a much better solution. He executes the civil servant. I did actually tell this to Labour ministers once, and there was a sort of wistful look, I have to say. So I won't tell which one. But anyhow, never mind. So what's that got to do with this? Well, it's got everything to do with what's happening in the technologies that we know and love. I've illustrated there Moore's law. We've been doubling the performance per unit cost, let's put it that way, of electronics pretty steadily every 20 months, near enough, since 1952. And there's actually no particular sign of it stopping. It's getting more expensive to continue. We're down to 33 nanometer spacings now in chips, but there are plans afoot to go down as far as 11, 12 nanometers. Immense amounts of work going on in lithography, extreme ultraviolet, and so on. When we finally hit the buffers on that, no problem, we'll just stack them in 3 dimensions instead. When we hit the buffers on that, I have little doubt we'll have cracked quantum computing by then too. So there's no particular reason to think this progression is going to stop. I certainly wouldn't bet against it. But it's not just processing. How about communications? This is fiber optics. We were talking outside about the plans to put 100 megabits to every business and so on in central Manchester. Well, 100 megabits down a fiber is nothing. As you'll see on this, the latest level, if I can read it myself, is 26 terabits per second down a single fiber. It's an interesting technical tour de force, but it is possible. And on that particular one, we've now had 43 doublings since about 1982. We used to be doubling every 8 months. We're now trebling every 8 months in the capability. Interesting. Magnetic storage is a bit disappointing. That's only doubled 30 times in cost performance, and it's not too bad. Let me just move on. So we're going to talk about GNSS. Let's talk about wireless. This actually isn't cost performance. This is the use of the radio spectrum per square kilometre, how intensively you can use this. And the guy who coined this one, a lovely man called Martin Cooper, had the distinction of actually hand-building the very first Motorola mobile phone. Those here will remember the Motorola brick. But he made the first ever cellular phone call. And at that time, there were 2 teams battling each other to launch the first cellular phone in the US. One was from a company long since gone called Western Electric, which was the arm of AT&T before the divestiture. The other was Motorola. And from a street corner in Lower Manhattan, our friend Martin Cooper made the first call. Would you like to guess where it was made to? It's obvious, really. He made it to the head of the other team, saying, "Mine's working, how's yours doing?" But he coined this, and he reckoned that we double the intensity of use of radio spectrum roughly every 2.5 years since Marconi made the first contact in 1895. And that's still going strong. There's Wi-Fi in this building. They'll shortly, well, Pache Ofcom's inability to actually arrange an auction. We might have 4th-generation mobile here in a couple of years' time. The Germans have it now, and so on. So my point to you is this, and it's illustrated by that chessboard. Once you get into the second half of the chessboard, the quantum of change every time you double is actually getting quite interesting. And this has an effect. What you've got is the cost of basic technologies. users, short-term demand, feeds back. This enormous structural demand for communications and IT. And it starts to underpin everything that we do in our society in ways that are really both a blessing and wonderful for me as an engineer of 40-odd years, but also potentially a great vulnerability. And we want to touch on some of that vulnerability this evening. But first of all, let's have a little bit of fun with the first half of the chessboard. I'm sure colleagues have seen this. That was the entire staff of the Microsoft Corporation in 1978. If you want to know which one he is, he's that one. That's Bill Gates. Now, would you have bought a used piece of software from these guys in 1978? Never mind. So they were a company of the first half of the chessboard. With all due respect to a lot of the good work that Microsoft does these days, I'm not convinced they're a company of the second half. But let's not dwell on that. I want to talk, and we come more towards GNSS, about vulnerability. And 2009, when all these were published, was a very good year for reports, as they say. If we look at those, the shared responsibilities one is one in which I was personally involved. That was done by the Institute for Public Policy Research. It was looking at the threats to UK national security going forwards. It's an interesting group. The two chairmen, one was Lord Robertson, a former Labour Defence Secretary and Secretary General of NATO. The other was Lord Paddy Ashdown for the Lib Dems. And we also had a minister that I used to work for in my 7 years in the public sector, which was Ian Taylor, a delightful man from the Tories. Ian, of course, was still a working politician. The other two were kind of not front line anymore, which made them much more fun, I have to say. And they weren't having to score points against each other. And I have to give you one Lord Robertson story, because I think it sums up something that's really quite good about some politicians. When he was Labour Defence Secretary, he was taken on the compulsory trip on a nuclear sub out of Rosyth. And the captain had been carefully briefed. You know, this secretary had not been on a nuclear submarine before. Ha ha. So they're trotting along going out to sea on the sail of the sub. And the captain says, well, I understand, Secretary of State, you've never been on a submarine before. To which Robertson is said to have turned to him and said, I'm afraid, Captain, you're very sadly misinformed. Very bad news. I distinctly remember being astride the sail of an American Polaris submarine in the Holy Loch in the mid-1960s, painting a large CND symbol on it. His views were somewhat different by the time he got to there. A delightful man. But anyhow, the point about shared responsibilities, I will come to in a second, but just to flag two others, particularly for the civil engineers that are here, the State of the Nation report, which was done by the Institution of Civil Engineers defending critical infrastructure, was also absolutely key and an excellent report. So there was a key concern in shared responsibilities, and I will confess to being guilty of this prose. It's something that greatly worried me. At the end of the 1990s, I was a founder member of a thing which is now called the Prime Minister's Strategy Unit, which meant that I got to do tasks specifically assigned by the then Prime Minister, Tony Blair. I did two, one of which was about making the UK the best place in the world for e-business by 2002, as it was in those days, or safely 3 years away. When I completed that report, and we published it, I went off to the Institute of Directors as their e-evangelist, going around trying to tell small business how to do this stuff. I thought it was a great job title, by the way, until I met IBM's metaverse evangelist and felt distinctly upstaged. But what I was doing with those small businesses and large businesses was saying, you have to run lean, you have to take out stock, you have to use these techniques to reduce the costs in your business. And I did that probably for 5 years with a lot of companies. And it was important to do, because without doing those things, they wouldn't be competitive. But it did start slowly to dawn on me that there was one huge vulnerability here. And that is that every time you do take out some stock, you take out some staff, you run more lean, you do rely on the infrastructure working. And your ability to cope with major disruptions of infrastructure is reduced. And that's really what's in this prose here. We have, as it says, outsourced offshore and embraced just in time with little heed for just in case. And so for about the last 5 years, I've been on a sort of guilt trip, trying to do something about the just in case. And part of this work on GNSS that we're going to talk about today relates to that. And so in fact, in the report, which we had rather a lot of recommendations, but the one I've highlighted at the bottom there, government should task CPNI as a Centre for the Protection of National Infrastructure, by the way, for those who don't know it, which is a division of the Security Service. A thorough analysis to which space-based technologies are embedded in our critical infrastructure. Now, in fact, CPNI didn't do a lot with that, but happily the Academy did. So let's take us to the Academy. That's the report, initiated in that period of 2009. Curiously enough, nothing whatsoever to do with the recommendations that the IPPR made, everything to do with the fact that at the time the US General Accounting Office was having a budget cutback and said, we don't think you need all of those satellites in orbit. Surely you could do with a few less. And there was a genuine concern that GPS might not be sustained because there wouldn't be enough birds in orbit, particularly if they lost one or two suddenly. That happily has gone away, but it raised the concerns in the Academy, and that led to the study which we're talking about tonight. So let me just share with you some of the range of applications that are there. The beauty of these technologies, particularly GNSS, is it's utterly ubiquitous, it's remarkably cheap, and just about everyone can find a use for it. So we'll talk about rail. If when you come to the station the doors fail to open on your train, it's almost certainly because it's lost the GPS signal, because it has to know from GPS where it is to open the doors. Some stations have shorter platforms, and it uses GPS navigation to know which doors to open and which doors not to. I have actually sat in a train in my station where it refused to open the doors because it lost the GPS signal. I was probably the only person on the train who understood what was happening. It didn't make it any easier, I have to say. Road is fairly obvious. Aviation, maritime, huge amounts of use in agriculture now for precision guidance of tractors and things of that kind. As we'll see in a minute, energy, and many, many applications. All I would say to you is that by being so useful across so many systems, what you end up building is what we as engineers would call an accidental system. There's a common link to all of these, a common vulnerability to all of these that is not necessarily well understood. And that was very much what the work of the Academy wanted to expose. So let's have a look. That gives you an idea of some of the vulnerabilities. They're not always immediate. Let me stress this. I'm not trying to be alarmist. If you take the link to the comms networks, for example, if you lose GPS, the timing of the comms networks doesn't stop. It just falls back to other sources. Depending on how good your provider is and how much money they spent on the other source, it may hold up for hours, it may hold up for days, it could hold up for weeks. Certainly there are big atomic clocks there. But in modern communication systems, particularly mobile communication systems, if you lose very accurate timing, the capacity of your system gradually degrades over time. These are code division multiple access systems in particular. So that's one vulnerability. The power grid takes its timing from GPS. Again, there are fallbacks. Virtually every high-value stock market transaction is time-stamped using GPS. Some of us may wonder about that, but that's another matter. And then you've got all the various navigation examples. And the one I want to show you later goes back to the traditional use of GPS in shipping and just what happens if it all goes horribly wrong, in this case deliberately. But it may interest you to know that, to the best of my knowledge, we're not training navigators either in commercial shipping or even in the military to navigate with anything other than GPS. So, compass, map, yeah. Very old stuff, right? But a little frightening, I have to say. And I think we've probably got a generation of young drivers now who would be lost without a GPS and a navigator talking to them. This is me getting old and grumpy, I'm sorry. But it's certainly true. So, let's have a look at the vulnerabilities. what's provided with GPS and any of the other constellations, and of course there are others, there's GLONASS from the Russians, there's COMPASS, which the Chinese are busy building, there's our own Galileo, which we're building. All of them share common modes of failure. And they're all used for both position and navigation and timing. And in fact, it's the timing that is the one that's most misunderstood in terms of its ramifications. Certainly we felt in the academy that loss of PNT could lead to all sorts of disruptions, many of them poorly understood because of this accidental system effect we might just explore in a little while. The other thing, of course, is that they may be lost deliberately. Jammers are cheap, widely available, not beyond the wit of a first-year engineering student, I would have to say. And the detection network, which they have in the States, JLOC, generates thousands of instances a day where GPS is being jammed on a local basis. There can be good reasons for this. Let me just share some with you. There's an interesting piece in The Economist last March which pointed out that the navigation systems at Newark Airport in the States were periodically going offline at a particular time of day. It took the FAA 2 months to track down the cause. And the cause was a chap driving a van down the New Jersey Turnpike at roughly the same time each day, who was deliberately jamming GPS so his employers didn't know where he was and couldn't track him. Happily, nothing bad happened, but could have done. If you're in Germany, your road tolling system depends on GPS. Now, it doesn't take a genius to work out that that might just be an incentive to jam it. And that is indeed what is happening in Germany. If you've just hijacked a high-value lorry load, and you're pretty sure it's got GPS tracking, if you're a crook, you're going to jam GPS. And they do. Police have been following that for the last 3 years with increasing intensity. And of course, I say, if we were daft enough to engineer a road tolling system in this country based on GPS, you know, I can predict to you fairly rapidly what the result would be. I think you can work it out too. So we have some interesting challenges here. And by the way, it's not just vulnerabilities of that kind. We're quite capable of messing it up ourselves. There have been 3 occasions now on which bad data has been uploaded to the entire constellation. The last one of those, I'm glad to say, was in June 2002. So we appear to have learnt a lesson there, but previously one happened in March 2000 and one happened in March 1993. The equipment tends to be distinctly dicey when you insert a leap second. One mobile phone's billing, one mobile company's billing, which would better be named nameless, was completely thrown by having a leap second inserted in GPS. Don't go there, you know. And of course, if you upgrade, the danger of the upgrade, there have been several upgrades which have virtually brought the network down by not being adequately tested before they were upgraded, or the upgrade actually revealed some slight flaw in the specification which was open to multiple interpretations, which only became clear when you put the upgrade in and various things fell apart. So, you know, this is not a completely secure system. Let's move on. You could protect it. There are some things that could be done. Use of adaptive antennas is a good one. A lot of it's quite high cost, and some of the technology is just simply not available to civil users. It's actually quite difficult. We talked about jamming, we didn't talk about spoofing. It's not that difficult to actually deliberately change the position that someone's seeing on GPS by deliberately sending it false data as opposed to simply jamming it. That has some quite interesting implications and consequences too. And I would share with you, manual systems are unlikely to provide a sensible backup to this, largely because people have forgotten how to use them and we don't test them. So, let's push on. So the key concerns that we surfaced in the Royal Academy of Engineering report were these. First of all, this ubiquitous reliance. Second, and we'll come to it a little bit later on, so-called out-of-cycle solar events. This is what's known as a Carrington event. Anyone, geographers here? Know a Carrington event? Okay, well the last Carrington event happened in 1859, so you can be excused. That it was the last really big coronal mass ejection from the sun where the Earth happened to be in just the wrong place at just the right time. In other words, it hit us squarely. And it did quite a lot of damage to the very early telegraph networks, like it melted some of them. And it certainly electrocuted a number of telegraph operators because it induces very large direct currents. What it would do to satellites in orbit, nobody quite knows because we haven't had one since 1859. But I would take a bet it would wipe out every single GNSS satellite and probably many of the ComSats too. So that might be an interesting challenge. The risk from jamming is growing, and just say a little bit more about jamming. We have what's called red team and blue team jamming. Red team is the bad guys, or other bad guys like those lorry hijackers. The blue team is the police. And if you're taking a very high value individual like a head of state, and you're worried that something might be detonated near them using GPS, then you jam GPS. And depending on how good you are at setting up your field of jamming, you may jam up quite a lot of other things at the same time. Happily, those things are usually moving at speed. But there's a lot of jamming that's actually done by legitimate law enforcement, which is interesting as well. There's a potential for a real own goal there because one of the things that's vulnerable to GPS is the police's own communications network. I'm kind of responsible for this because I made its spectrum available when I ran the Radio Communications Agency. Those here may remember the King's Cross Tube disaster down south. One of the great findings was, guess what, the police and the fire and the ambulance couldn't talk to each other. So a common system was built for them called Tetra. Guess where Tetra draws its timing from? GPS. So if you, as a policeman, jam GPS in the vicinity of a Tetra base station, you may have just scored a rather spectacular own goal. Right? So these are the sorts of vulnerabilities that are there. So risk of jamming, risk of spoofing, and as I say, all the constellations, including the Compass one the Chinese are busy putting up, and the Chinese aim to have about 32 satellites up by 2020, are all vulnerable in exactly the same way. So what are the implications? Perhaps this is not surprising. We're dangerously dependent on it. There are backups, and I want to come to those later in this presentation. They're a wonderfully British, done on a shoestring, nobody wanted to support it thing, but we'll come to it. The backup systems are often inadequate or untested, absolutely. If you Google GPS jammers on the internet, you'll come back with really rather a lot of them. And they're small and they're cheap. And by the way, it's not illegal to sell them, which we'll come to in a minute as well. It is, of course, illegal to use them. Right. Wonderfully British approach to law. But there are ways we could mitigate, and I want to share with you some of those. So let me come to this practical demonstration. I need to just explain a little. This wonderful organisation, the General Lighthouse Authorities of the UK and Ireland. GPS is accurate, but if you want very high precision, for example, if you're docking an oil tanker, you might want to go a little bit more. And that's differential GPS, and the General Lighthouse Authority runs the base stations. There are 14 of them around the coast, which do differential GPS. So that's their aegis on this. They have a very simple view. They don't like the GNSS vulnerability. They can see an accident waiting to happen. The international maritime regulations say these systems should be resilient, and to be blunt, GNSS is not. And we'll come back to that in a minute or two. So, to demonstrate this, they set up a jammer on Flamborough Head, aiming out to sea, I have to say, and that was done in 2008. It had some quite interesting consequences. They warned all shipping to stay out of this cone, by the way. They then sailed one of their own craft into it to see what would happen. And what actually happened was quite interesting. Amongst other things, the vessel decided it was from time to time actually in the middle of Bridlington, which would have come as to a surprise to the shoppers, and also was doing more than 100 knots, which came as a surprise to the captain. Let's just say that the systems on board behaved very unreliably, and on some occasions were visibly so, on other occasions were subtly so in ways that could have been really dangerous. I won't go into the detail of that one because it's a rather better one, which this is the THV Galatea. And what they did there was to put a jammer on board the boat rather than having it on land, and just gradually increase the power to see what failed. And this was quite interesting. Probably can't see very clearly on that slide. But there is a massive difference between where the ship actually was, the true position, which is in green, and where the GPS was indicating at the point that particular chart was up on the screen. The green circle came from a thing called ELORAN, which we'll come to in a minute, which is the wonderful British solution to this, which still hasn't had proper support from government. Okay, let me just share with you then what actually happened. So, with low power jamming, it caused what the navigators call hazardously misleading information. In other words, no alarms, just false readings. So it was significantly off in position and speed. As they increased the power, it showed it being in all sorts of interesting places, including right up in the north of Norway, which was quite interesting. But the really challenging ones are the erroneous positions and velocities that were subtly out. Also, as they upped the jammer power, all sorts of things started to go wrong on the bridge, not just the navigation. And at this stage, the bridge team, even though they knew they were causing this trouble themselves, lost situational awareness. They were completely bemused by what was happening. You can imagine what it would have been like if they hadn't been prepared for it. So they lost their electronic chart display, they lost the autopilot, they lost the GPS, not surprisingly, they lost their helicopter deck stabilization, they lost their maritime distress and safety system, they lost their radar, which was drawing timing from GPS, they lost their gyro compass, and they lost their automatic identification system of other vessels. If you can imagine each one of these is accompanied by its own distinctive alarm, it's not a lot of fun to be on the bridge of a boat under those conditions. So it just illustrated, even for our own navigation folks, just how serious this is just for shipping. So, let me push on a little. There is, as they say, an alternative. And let me tell you a story. When I was researching this report with the team, I went to visit Trinity House. I did enjoy doing that because I'm married to a lass from Hull, and 6 of her uncles were master mariners. So they had a certain affinity, all not all dead I'm afraid, for Trinity House. And I met the lady who runs all their navigation systems, a most impressive lady. And she had come up with this thing called ELORAN. LORAN is a very old navigation system. LORAN C has been around for donkey's years. It's a high power, medium frequency system, not terribly accurate. And what she and her team at Trinity House had done have made it accurate to 10 meters. And with 1 or 2 little advantages over GPS, like assuming you want to use it on land, in building penetration, which you're not going to get with satellite. And she was desperately trying to find £200,000 from somewhere in Whitehall to continue funding this thing, because nobody wants to touch it with a stick. And yet, and at the same time, the Americans were shutting all of their LORAN C stations. Right? This is the solution that we believe, the General Lighthouse Authority certainly believes, I think we in the Academy believe, completely independent, completely complementary to GNSS, high power, low frequency, not satellite, not low power. Dead easy to integrate even into the GPS chipsets if we wanted to. And it meets all the maritime performance requirements, as this was developed for maritime use, but the other uses would work. And again, we still haven't quite decided whether we want to support this. It's unbelievable. Just a little bit more about it. Precise timing, independent GNSS. All the things you expect with GNSS, which are things like correction factors for propagation, differential use. You can have differential ELORAN as well as differential GPS. all of that works. And there are some illustrations here. By the way, all of these slides are available to you. I'll give you a download address at the end if you want to see them and play with them. And if you want to follow up, I'm sure my friends in the General Lighthouse authorities will welcome your support. And this is what we have. We've been running this routinely now for a long time in the UK. 99.9% availability on the transmitters. Could be much higher. Prototype differential LoRaNs working in Harwich. Positive Department for Transport decision expected, said he, hopefully. We shall see. Yeah, dream on, as you say. And it could be made to work with other systems in Europe, including a Russian system called Chaika. So, that's one of the solutions to this. The problem is GPS is so cheap, it's so ubiquitous. Why do you want to back up to it? Well, I hope I've shared with you some of the reasons why you should. Let's now have another one, space weather. I only put that in because it's such a pretty picture. That's the sun in a bad mood. So what you're seeing there is the solar corona from a satellite called SOHO, which is permanently observing the sun. It's a useful satellite, SOHO, because if you did get a big coronal mass ejection, there was a lovely front cover on New Scientist about 18 months ago, which had the headline, How to Turn the US into a Third World Economy in 90 Seconds. That satellite sits watching the sun, trying to give you that 90 seconds, amongst other things. So, what can upset GPS? Well, there are three things there. There's electromagnetic radiation, delay of 8 minutes, cosmic rays, enhanced solar wind, and with it, these coronal mass ejections. Electromagnetic radiation we're used to handling. It reduces the signal-to-noise ratio, but it's not really. All of these we can handle. If you excite the ionosphere, it will cause delays in the GPS signal. You can get some scintillation. All of those we've had many years now working out how to compensate for, how to manage. So that's okay. But actually, it's partly okay because we don't sit in the bit that's nasty. The UK, as you can probably see, is way up the top there in the nice blue bit called infrequent. It's slightly more worrying if you're in South America or Central Africa or over here, where the disturbances are much greater. Let me come back, though, to these superstorms that I started with. This is slightly speculative. It's done with radiation records taken from ice cores and things of that kind, as we weren't measuring too well in the 1600s. But the one that stands out, as you can see, is the Carrington event in 1852. We have not had an event on that scale in the space age. Views vary on how often we should expect one, from somewhere around once in 100 years to once in 500 years. It's actually a matter of geometry. There are many coronal mass ejections. What's the probability of we would be directly in line with one at the time? And that's not a difficult mathematical thing to solve. Quite interestingly, in the most recent revision of our National Risk Register as a government, this one's gone right up the list. It wasn't even on the list a couple of years ago. It's now regarded as really quite a serious risk, given the impact it could have across a lot of infrastructure, not just GNSS. I say I don't think it would burn out our power grid, but I don't think I want to run the experiment. It would certainly cause great grief to the Americans. Some of these smaller storms, this one in particular, caused quite major damage to the Canadian power grid, even on a smaller scale. So, you know, this is reasonably well understood what the problem is here. Good. And even in normal operation, the way in which the solar wind interacts with our ionosphere does cause you grief. So, for example, what this is showing, let's put you up both charts. That one is when all is quiet in the ionosphere. This is when it's been stimulated a bit, not by a superstorm, but just by a reasonable injection of solar radiation. What you can see then is really quite significant delays going on. And this is a differential system. Wide area augmentation is what the Americans use to try and manage the errors in GPS for satellite, for aircraft use, for precision approach and landing. And you can see, under some conditions, it's working pretty hard to try and keep the GPS running. And even with that correction, you're getting errors up to 35 meters, which probably doesn't mean you want to land with that. Yeah. Though I have to say, I remember landing at Heathrow once on a 747, where it bounced fully 4 times before it came to a halt. And the captain, in that voice that only British Airways can do, came on and said, "Ladies and gentlemen, I'm sure you'll be glad to know that was an entirely automated landing. Brackets, not my fault." Right. Quite. But that might be pushing your luck. Anyhow. So, I want to get on to the recommendations of the report. We were very concerned as the Royal Academy of Engineering that people were not taking this as seriously as they should, and that there should be explicit consideration of these GNSS vulnerabilities, both in terms of the companies that provide critical services, and by the way, that's an enormous breadth of companies these days. It's not just a few. And also the national and regional emergency teams who are responders. But let's say a few kind things about government. The way in which the UK manages this through a thing called the Cabinet Office Civil Contingency Secretariat is really good. CCS was set up in about 2001, 2002. We aren't perfect, that's for sure, but we're streets ahead of many of our European colleagues in having assessed these things, have tested them. I'll give you one example for the engineers that are here. It had been quite a few years since anyone had thought about trying a black start of the UK power grid. And it's not something you want to do sort of on a wet Friday night because you're bored. Right? The last time we had a black start of the power grid was something that didn't, sorry, it's always great fun to say this in Manchester. It caused great consternation because it happened in London and it was the Great Hurricane. Right? Didn't actually raise much of a flutter up here, but it did a fair bit of damage down south. It also took out the national grid for the first time since 1948. But we do have to understand these, and including the responders. But I say, to complete that story, our friends in the CCS decided there ought to be at least a desk test of a black start of the grid. And of course, when they tried it out, it didn't work. Because since we had the Great Hurricane, we got rid of a lot of coal, and we got a lot of gas. One snag about gas, coal is sitting there. You can just shovel the damn stuff in if you have to. Gas, you've got to pump. What do you need to pump the gas? And the first black start didn't work because there wasn't power to power the pumps to get the gas to the stations to maintain the system. So again, you've got to test, and they did. And so I've got a great deal of time actually for some of the things we do in the UK in this. So, but if we move on to 3, we wanted people to document what they would do in a GNSS outage of various lengths. If you lost it for 5 minutes, probably not a problem. Lost it for 3 months, that might be more serious, even for the telcos. Then, in my old neck of the woods, I used to be the Chief Executive of the Radio Communications Agency, now the biggest part of Ofcom, fix this remarkable piece of stupidity in British law and make it illegal to import, advertise or possess jammers, not just using them. Hasn't happened yet. Put in place a system to monitor the disruptions. The Americans have that with JLOC. We don't really. We have something called Guardian. It's not quite there. Let's carry out a few tests. Let's deliberately jam GPS over a certain area and see what fails. Now this might be a bit of a challenge. I do remember going to a central London government department and saying, I would really like you to explain to me how you test power failure recovery of your computer centre. They said, it's very simple. We wait till midnight, we power everything down, we turn the power off, we turn the power back on again, we power everything back up. I said, do you think that's remotely sort of realistic? They said, oh no, but if we just turn the power off, it might break something. I'd just not. Anyhow, so proper tests might be a good idea. We don't want to wake up one morning and find a road user charging system based on GPS. We really, really don't. And indeed, even stolen vehicle tracking systems. We need to think about that. And this business of having a high-quality source of position, navigation and timing independent of GPS, which is not Galileo, which we're spending a huge amount of money on, not Galileo, we felt was really very important, and that could easily be ELORAN, as indeed it says here. So, that was it. Let me just share with you some final thoughts. I do like this picture. I'm sure it's a fake, but it's such a good fake. Okay. Legible? Yes, it is. Okay. So I think we're already dangerously dependent on GPS as a source of position, navigation and timing. It's this accidental system approach. And let me just tell you another example which is very close to home here of an accidental system. Some in this room may remember, it must be about 10 years ago. Someone opened up a manhole cover in central Manchester, poured some flammable liquid in and chucked in a match. It was either an interesting accident or a very carefully chosen manhole, because what it did, and the resulting fire in the cable chamber underneath, took out police communications across 3 counties, ambulance communications across 3 counties, bank cash dispensers across 2 counties, and quite a lot of other things. All of those things, people thought that they were multiply diversely routed and had a separate communication systems on different carriers. Unfortunately, they all went through the same manhole. They got an accidental system based around that one particular geographic location in Manchester. So it didn't matter whether they were on BT or Carrier X. The physical cabling went through that same manhole. And we have a bit of that with GPS. The backup systems are often inadequate or untested. We can go out and buy a jammer really very easily. We could probably build a spoofing machine really very easily. None of us has a full idea of the dependencies that hang off this and the breadth of the accidental system that we built for all the right motives, because it is so useful and so cheap and so ubiquitous. But we could be mitigating these. Different technology, something like ELORAN, actually very cheaply. But we aren't really doing it yet. So that's it. I also should acknowledge on the bottom of there, thanks to my colleagues, and particularly Paul Cannon and Nick Ward, who provided the slide material on the solar storms and the Lighthouse Authority, particularly. And just as an end note then, to say you don't need new technology to have a really bad day at the office. One of my favourite pictures, not least because it's French, that's the Gare de l'Est in Paris. And I say, I'm sure his position, navigation and timing didn't work terribly well. But if you want to download the slides, I will leave that up. That's the reference to pull them down.